Welcome back. Here we go with our first lesson of second semester. So I'm going to start over calling it lesson 1. We're going to do a little review today, a little practice of properties of exponents, practice using the properties of exponents to simplify expressions. So we're going to use properties of exponents to simplify expressions using positive, negative, and zero exponents. So this first part is just a little bit of a review. Remember, if you're combining like terms, so if you were trying to add like terms and you had, say, 2x cubed minus 4x squared minus x plus 3x cubed. That was supposed to be cubed. In order to add or subtract, we need like terms. And that means that they have the same variable with the same exponent. So this first term and this last term would be like terms. And when we are adding and subtracting, we only add or subtract their coefficients or the numbers in front. We don't touch the exponents. The exponents just have to match for us to be able to combine them. When we're multiplying, however, and so I did it with these first two powers. I'm not going to do all of them this way. When you're multiplying, the exponents are affected. So x to the third means x times x times x. That's what exponents mean, is that you're repeatedly multiplying. And then x to the fourth is 4x's multiplied. So if you write it out this way, you can see that we are now multiplying 1, 2, 3, 4, 5, 6, 7 x's. So x to the 7th. That is called the product of powers. When we multiply two things that have exponents, the exponents do not have to match, and we add their exponents together. So you can see, if you can see down here, over here, a to the m times a to the n, they have to have the same base because you have to be multiplying the same thing. They have to have the same base, and then we add their exponents together. 3 plus 4 is 7. So I wanted to take one where I wrote it all out and kind of showed you why we add those exponents, why that happens. It's not just a made-up rule that somebody did. There's a reason behind it. When we're dividing exponents, so x to the 6th means x times x times x, 6 of them. X to the 2nd means x times x. So if we write it out that way, we could simplify it by, like, these two x's would equal 1 because something divided by itself is just 1. And these two x's, x divided by x equals 1. So both of those reduce to just 1. And then I have 1, 2, 3, 4 x's left. So this one's called the quotient of powers. And this didn't come out right. It's supposed to be a to the m minus n. There's only one a, one base, and you subtract exponents. So if you're dividing, you can combine them into a single x and you subtract their exponents. I kind of actually don't think of it as as subtracting. I think of it more as crossing them out and simplifying like this. And I'll show you why when we get down a little bit later. There are some other properties that I'm not going to write out this same way. I could show you why they work, but we're not going to. Man, I have another typo. This should be an M. Yeah, that should be an M. Okay, so power of a power. When you have a single base and it has two exponents, using parentheses, and it has two exponents, you can combine them and you would multiply the exponents together. If there's more than one thing inside the parentheses, you would distribute it. So if you had like a 2x to the 2nd, y to the 3rd, and then had an exponent of, say, 4, that exponent would actually go into each one of them. But if you have a power to a power, you multiply the exponents. This kind of shows those two combined in there. If you have more than one thing inside the parentheses, then you distribute the exponents. So you'd get a to the m and then also b to the m. Negative and zero exponents, that stuff you've all worked with before. Negative and zero exponents you probably haven't worked with as much, and they're the ones that tend to trip people up in advanced. If you have a negative exponent, you can change it to a positive by taking the reciprocal. So this right now is like over 1. I can move it to the bottom of a fraction, and that exponent changes to a positive. It would work the same if, say, I had 3 over x to the negative 2. If I have a negative exponent, I can change it to a positive by moving it to the opposite side of the fraction. So since this is in the denominator right now, I can move it up to the top, and the exponent would change to a positive. It wouldn't affect the 3 because the 3 doesn't have an exponent. It would just change the exponent to a positive. And the last one is called the zero exponent. Anything raised to a 0 power just equals 1. So we have just a whole ton of problems to do. We go all the way down, tons of them. What I suggest is watch one and then pause it and try the other one. So like A and B, these are 2 of the same type of problem. Take notes while I do the first one, and then pause the video and see if you can do the second one. And then take notes while I do C and pause the video and practice D on your own. That's what we would do in class. I would have you try one and then we would do it together. So it's a great way for you to do it here also. So this first one, we are multiplying 16x to the 4th by 2x squared y. When we multiply, we already talked about up above that you add coefficients, you add exponents. We are going to multiply coefficients. So if there are numbers in front, you multiply them just like you normally would. 16 times 2 is 32. And then you add exponents. So these x's with the same base, they have to have the same base. I have x to the 4th times x to the 2nd, so that's x. And then I add exponents to the 6th. There's only that one y, there's not another one, so that just stays y to the 1st. Okay, did you pause and try this one? Let's do it together. -5, we're going to multiply coefficients. -5 times -11 is positive 55. I can combine the x's, multiply the x's. Remember for this one, if there's no exponent, that means that it's a 1. So x to the 3rd times x to the 1st, I add their exponents and get x to the 4th. And then I can also multiply the y's. Y to the 5th times y to the 4th is y to the, multiply their add their exponents, y to the 9th. So that was the product property. The next one is the power property, saying when you have an exponent, so like these, I'm going to write this one out the first time. First of all, I'm going to distribute this exponent. So I have 4 to the 4th, and then I have x squared to the 4th. You don't have to do this every time. I just want to show you once. And then we have y to the 5th to the 4th. So that exponent gets distributed in to everything. Now I'm actually going to simplify. So now I'm going to simplify each of those. 4 to the 4th is 256. X to the 2nd to the 4th, when I have a power to a power, so one variable with 2 exponents, I multiply them, and I get x to the 8th. Y to the one variable with 2 exponents is a power to a power. We multiply exponents. Y to the 5 times 4 is 20. So if you think about like this one, let's do this one really quick. Just because otherwise they seem like just these random rules that someone made up. X squared to the 4th means 4 of those x squared. So it means x squared times x squared times x squared times x squared. It means 4 of them, right? So now I'm back to the product property. When I'm multiplying things with the same base, I add their exponents. So these all have a base of 2, and I'm multiplying them, so I add their exponents. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So that's why you multiply if you have a single base with 2 exponents. Okay, so here's your pause. Pause the video and try D. Okay, so I'm going to distribute the 4. I'm not going to write it out this way this time. I'm going to distribute the 4, just because if I was a kid, I wouldn't write that step. So -6, use parentheses on your calculator. Hint, don't use a phone calculator. They are the worst. Use either an online or an actual one. Phones are terrible. So -6 in parentheses to the 4th power is 1,296. It is positive. If you get a negative, you didn't use parentheses. X to the 3rd, and then to the 4th, I have a single x with 2 exponents. So I multiply exponents and get 12. Y to the 5th, and then to the 4th. So a single y with 2 powers. I multiply them. 5 times 4 is 20. Okay. Our next set are division, and I will explain the first one both ways, both using the technical properties and then using the way that I think about it. So we're going to go through each matching term and basically just reduce them, right? So we'll do 4 over 8. Can you reduce that fraction 4 over 8? Well, 4 goes into 4 once, 4 goes into 8 twice. X to the 8th divided by x to the 8th, those are the same. Something divided by itself is just 1. So those just equal 1. I don't need them. And then y to the 5th over y to the 6th. When you divide, you subtract exponents. I'm going to start with the 6 because that's bigger. There's more of them down there. 6 minus 5 is 1. Because when you divide, you subtract exponents. But here's where the mistake comes in. You started with the 6 and it was on the bottom. So that y to the 1 is going to be on the bottom. So you get 1 over 2y. When I think about it, so this is where I said I do it a little different. I'll show you on this second one over here. So again, we're going to simplify the coefficients. 20 divided by 4 is 5. Then when I do the x's, I think about them in terms of canceling out. So remember back up here, when I wrote all of them out and I cancel them out, that's the way I do it. I just don't actually write it. Like I kind of imagine that happening. I think of that happening. So you have 1 down here. I'm going to erase these for a second. You have an x to the 1st down here. So that 1x would cancel out one of these and you would have 4. So it's the same thing you get. If you did 5 minus 1, I don't know, I think of it that way. So I would get x to the 4th. And then for the y's, this is like a y to the 1. There are 8 y's on the bottom, right? Like if I wrote them out, y, there are 8 of them. This y on top would cancel one of those. So this one would be completely gone, and one of the ones on the bottom would be gone. So I would have 7. So I get y to the 7th in the denominator. How you doing? Pause and take a break if you need a little break. Okay, we're on the last page, the home stretch. These two we're simplifying. We're adding in not only fractions now, but some negative exponents. So there's not one correct order to do these in, okay? I'm gonna show you the way I do them, and then I'm gonna show you the way I do them. So I would, since I have two y's on the bottom, or sorry, two y's on the top and two x's on the bottom, I would combine those first. So I would simplify the top first. So y to the -1 and y to the -5. I have two y's. They are being multiplied, so I add exponents. -1 plus -5 is -6. And then I'm going to do the same thing in the denominator. I have two x's down here, so I'm going to simplify this denominator. I have two x's. I am multiplying these terms, so I add exponents. 8 plus -2 is 6. Okay? However, we're not allowed to leave negative exponents. We can't leave this up here because its power is a negative, and we don't leave answers with negative exponents. So I'm going to move this y to the -6th down to the bottom of the fraction. And by moving it, all that happens is that you change the sign of the exponent. So I have an x to the 6th, and now I have y to the 6th. There's nothing left on top, right? There's no x's, no y's. They can't have a fraction with nothing on top. What was the coefficient here? What was the number in front? There was a 1. If there's not a number in front, it's automatically a 1. So that 1 is still up there. Okay, let's do the same on this one. Although you could pause first. There's only the x to the 6th on top, so I can't simplify that. I can't combine it. But these two I can combine. X to the 4th times x to the 3rd. I'm multiplying two separate x's, so I combine them and add their exponents, x to the 7th. They're both positive, so I don't have to worry about that. But I have two terms with x's. This is not simplified as far as it can go. So what we can still do is, just like on the previous page, think about if we had 6 x's multiplied all out on top and 6 x's on the bottom. These 6 will cancel out 6 of these. So 6 of these are canceled. There were 7, so that means there's 1 still left down there. So I have an x to the 1st in the bottom. All the x's are gone up top, so all that's left over is the coefficient, which is a 1. Here's a little bit more practice now with negative coefficients, or sorry, negative exponents. So write the following expression with no negative exponents and no parentheses. We have to get rid of the parentheses. We have to get rid of the negative exponents. So we're going to have to distribute. So I could distribute the 3 in first, or I can deal with the negative exponent first. I'm going to have to do both. You can choose which one you want. I want to deal with the fact that it's a negative first. So right now it's not written as a fraction. If I have a negative exponent, I need to move it to the other side of the fraction. So if it's not written as 1, that means, remember, it's automatically over 1. So I'm going to take this whole thing, because it's all grouped together in parentheses, it's all one thing, and move it to the bottom of the fraction to change that exponent to a positive. So that exponent will become a positive 3. It only changes exponents, so it doesn't change the 2 at all. The -2, it doesn't change that. It only changes the exponent. Now I'm going to distribute the 3 into both of them. -2 to the 3rd is -8, and then x to the 3rd. Like I said, you could have done the distributing first. That would have worked as well. So the difference, this one, I wanted to do one that's really similar. This one just doesn't have parentheses, right? This one had quantity -2x to the -3. This one doesn't have parentheses. That means that -1 is only on the x, not the 2. It's like -2 times x to the -1. The -2 doesn't have that exponent because there's no parentheses. So the negative 2 is totally fine where it is. The only negative exponent is this negative 1. So I need it to be a fraction so that I can move it. I'm going to move this x, because it has the negative exponent, to the denominator, and the exponent will become positive. The negative 2 is not affected. It stays up there. If you want to leave this 1 in front, you could. We just don't need 1s. I don't need any of those. So it's just negative 2 over x. And then the last 3, we're just throwing stuff at you. Just, what can you do? What can you do? They get ugly. They get uglier. These are all pulled straight from a Desmos or your Delta assignment, though, so they're good practice problems. Okay, so express the following fraction in simplest form using only positive exponents. You can see there's 3 levels in Delta. So I did level 1, then this gets a little bit worse, level 2, and then this is worse, level 3. So these follow the 3 levels in your assignment. Okay, so this first one has parentheses. I'm going to need to start out by distributing that exponent. So I get 4 squared is 16. And then z to the, I have a single variable with 2 exponents. So a power to a power, I multiply them. Z to the 8th over 12 z to the 7th. And now I'm going to reduce. So 16 over 12 as a fraction. I can reduce that. They're both divisible by 4. 16 divided by 4 is 4, and 12 divided by 4 is 3. Then I'm going to reduce the z's. If we're doing it my way, these 7 will cancel 7 of these. There were 8 of them. I canceled 7. That means there is only 1 left up there. So a z to the first. Make sure you have only positive exponents, no negatives. Okay, let's do L. I'm going to do what we did up above where I distribute, right? I still need to distribute. Just make sure that you don't go to the 5. 5 is not in parentheses. It's not part of the group. So 5 is just 5. A power to a power. So negative 3 times 2 is u to the negative 6 over 2 u to the 8. So we need to reduce. 5 over 2 does not reduce. They have nothing in common. And I can only have positive exponents. I have a negative exponent here. The u is the negative 6 power. So to fix it, I'm going to move it to the bottom. I already had the u, or 2u to the 8. And now I also have a u to the 6th in the bottom. And it becomes a positive. When I move it, it becomes a positive. So now one last step, I can combine these two. U to the, I have 2 separate u's that I'm multiplying. I add their exponents and get 14. Now you could have skipped this middle step if you know that when you move it down, you're going to combine it with the u's already down there. You could leave this step off. All right, let's get this big one. Finish up your first notes of the semester. Here again, we could, you can't simplify first because there's the exponent, but you could distribute the negative 4 first, or you could move it all down to the bottom. I'm going to distribute. So I'm going to take that negative 4 and go 1, multiply it there, multiply it there. So I get 5 to the negative 4. S to the 4th to the negative 4th. So I have a single s with 2 exponents. I multiply them and get negative 16. Q to the 1 and 4 is 4. Okay, so let's move the stuff that needs to be moved. Yeah. This 5 has a negative exponent, so I'm going to move it down to the bottom. So I get 5 to the 4, and then I already had this 5 down there. I'm going to move this s to the negative 16 down to the bottom and change it to positive, or s to the positive 16. I could move the s cubed if I want, but I don't want to, and I'll show you why. And then lastly, these q to the fourths, neither of them need to be moved, but if I have 4 on top and 4 on bottom, or if I have q to the fourth divided by itself, that just equals 1. So all the q's are gone, that just equals 1. So this is it. I just have a 1 left over on top. So I have 1 over 5 to the 4 times 5 is 3,125. I could move this s to the negative 3 up to the top and then reduce them. That would be one way to do it. Let's do that down here. So if I moved this s to the 3, that would become positive on top, and then I'd have 16 on bottom, and now I would have to reduce them. So I could do that. It would be totally fine. So these 3 on top would cancel out 3 of the 16 on the bottom, and I'd have 13 left. That's one way to do it. Or we can leave them down here, and when you multiply an s by an s, I add their exponents. 16 plus negative 3 is just 13. It didn't end up being negative, so I didn't have to move it. So there's a lot of these problems that there's not one specific order that you have to do it in, which is good, but also some people find that frustrating because they want like a step-by-step list.